Introduction. Hey Suman, can you help me in expanding these expressions?
Yes, sure. Show me. When we expand x plus 1 square, we get x square plus 2x plus 1. And when we expand x plus 1 cube, we get x cube plus 3x square plus 3x plus 1.
That was easy. Can we expand x plus 1 raised to power 4 or x plus 1 raised to power 5?
Yes, we can expand them too. But when we try to solve them, we can find that this method becomes tedious. So we use binomial theorem to expand these expressions.
Binomial theorem? That's a new term I am learning about. Tell me more about it.
Okay, come. I'll tell you about binomial theorem in detail.
Objectives. At the end of this lesson, you will be able to write binomial coefficients, understand Pascal's triangle, learn binomial theorem for any positive integer n, learn general term of binomial expansion, write middle term of binomial expansion, binomial theorem for positive integral indices. A binomial is an algebraic expression that contains two terms. For example, x plus y. We are going to multiply binomials. The numbers that appear as the coefficients of the terms in a binomial expansion, called binomial coefficients. The binomial coefficient of n and k is written as Pascal's triangle. The Pascal's triangle lists out all the binomial coefficients as shown in the figure. The zeroth row is the coefficient in the expansion of x plus 1 raised to power 0, or simply 1. From the first row onwards, the nth row contains the n plus 1 coefficients in the expansion of x plus 1 raised to power n. As we can observe, there are some intriguing properties in the Pascal's triangle. The triangle is symmetric about the middle of each row. That is, NCR is equal to NCN minus R. Except for the leftmost and rightmost numbers in each row, every number is the sum of the two numbers directly above it. That is, NCR is equal to n minus 1 CR minus 1 plus n minus 1 CR. In every row, the numbers first increase from 1 to a maximum value, then decrease back to 1. The second number as well as the second last number in the nth row is n, that is, nc1 is equal to ncn minus 1 is equal to n. Binomial theorem for any positive integer n. The formula by which any positive integral power of a binomial expression can be expanded in the form of a series is known as binomial theorem. If x and a are real number, then that is, x plus a raised to power n is equal to summation from r is equal to 0 to n of ncr into x raised to power n minus r into a raised to power r. Binomial theorem can be proved by induction. Properties. There are n plus 1 terms in the expansion. The sum of the exponents of x and y in any term of the expansion is equal to n. The binomial coefficients of terms equidistant from the beginning and the end are equal, since NCR is equal to NC n minus r. The term NCR into x raised to power n minus r into y raised to power r is the r plus 1th term from the beginning of the expansion. It is usually denoted by TR plus 1 and is called the general term of the expansion. The rth term from the end is equal to the n minus r plus 2th term from the beginning. That is, ncn minus r plus 1 into x raised to power r minus 1 into y raised to power n minus r plus 1. The term independent of x contains no x. Hence, find the value of r for which the exponent of x is 0. Examples of binomial theorem. Example. Find the expansion of a minus x raised to power n. Solution. We know that a plus x raised to power n is equal to a raised to power n plus n into a raised to power n minus 1 into x plus n into n minus 1 by 2 factorial into a raised to power n minus 2 into x square up to x raised to power n. Put x is equal to minus x in the above expansion. We get a raised to power n minus n into a raised to power n minus 1 into x plus n into n minus 1 by 2 factorial into a raised to power n minus 2 into x square up to minus 1 raised to power n into x raised to power n, general term of binomial expansion. In the expansion of x plus a raised to power n, r plus 1th term is called the general term, which can be represented by tr plus 1. tr plus 1 is equal to ncr into x raised to power n minus r into a raised to power r is equal to ncr first term raised to power n minus r into second term raised to power r. Example. Determine the fifth term in the expansion of x plus 2y raised to power 10. Solution. The fifth term in the expansion of x plus 2y raised to power 10 is given below. Three 3360 into x raised to power 6 into y raised to power 4. Middle term of binomial expansion. Let us now find the middle terms in binomial expansion. X plus y raised to power n. Two cases arise depending on index n. Case 1. When n is odd. There are two middle terms in binomial theorem. N plus 1 by 2th term and n plus 1 by 2 plus 1th term. Case 2. When n is even. When the binomial index n is even, we can see there is only one middle term, and it is tn by 2 plus 1. For example, if index n is equal to 6, an even number, then the middle term will be tn by 2 plus 1 is equal to t6 by 2 plus 1 is equal to t4. Example. Expand x square plus 3 raised to power 6. We need to start our answer by plugging the terms and power in the binomial theorem. The first term is x square. The second term is 3. And the power, that is n, is 6. So, counting from 0 to 6, the binomial theorem given as x square plus 3 whole power 6 is equal to 6c0 into x square raised to power 6 into 3 raised to power 0 plus 6c1 into x square raised to power 5 into 3 raised to power 1 plus 6c2 into x square raised to power 4 into 3 raised to power 2 plus 6c3 into x square raised to power 3 into 3 raised to power 3 plus 6c4 into x square raised to power 2 into 3 raised to power 4 plus 6c5 into x square raised to power 1 into 3 raised to power 5 plus 6c6 into x square raised to power 0 into 3 raised to power 6. After simplification, we get is equal to x raised to power 12 plus 18 into x raised to power 10 plus 135 into x raised to power 8 plus 540 into x raised to power 6 plus 1215 into x raised to power 4 plus 1458 into x raised to power 2 plus 729. Example. Find the fifth term of 3x minus 4 raised to power 12. Solution. Given r is equal to 4, first term is equal to 3x. Second term is equal to minus 4. N is equal to 12. On substituting these values, we get T5 is equal to 12c4 into 3x raised to the power 8 minus 4 raised to the power 4. On solving, we get 83,140,9920 into x raised to power 8. Did you know? Pascal's triangle was originally developed by the ancient Chinese, but Blaise Pascal was the first person to discover the importance of all the patterns it contained. The term binomial coefficients was first introduced by the German mathematician Michael Stippel in approximately 1544 AD. Summary. Let us summarize what we have learned. The expansion of a binomial for any positive integral m is given by binomial theorem, which is the coefficients of the expansions are arranged in an array. This array is called Pascal's triangle. The general term of an expansion. In the expansion, a plus b raised to power n, if n is even, then the middle term is the n by 2 plus 1th term. If n is odd, then the middle terms are n plus 1 by 2th and n plus 1 by 2 plus 1th term.